Hi, welcome to Pre-Algebra lesson 10-3, draw triangles with given conditions. In this lesson, we'll be able to draw triangles when given information about their side lengths and angle measures. So let's start with solve and discuss it. Kane has 4 pieces of wood available to build a triangle-shaped garden. Which pieces of wood can he use? So we have all these different types of different pieces of wood, right? We want to build a triangle-shaped garden. Which pieces of wood can he use? So the question is, which pieces of wood can he not use? Like, why would there be a piece we can't use, right? So you need to think about this. In order to be a triangle, right, you need to have 3 sides, and you need to have that's very obvious. But think about these 2 woods, the shortest woods, right? The shortest pieces of wood, 2 and 3 feet. Could we use 5 feet? You can say yeah, but think about it. We have 2 feet here, 3 feet here. If we have 5 feet, it's probably not going to be enough because they need to be flat. 2 plus 3 is 5. So this is not going to be a triangle. It is going to be a straight line, right? So yes, there are pieces of wood we cannot use at this point, right? So if 2 sides add up to be the 3rd side, we cannot use it. And the 2 sides must be bigger than the other side, right? So yes, other than 2, 3, and 5, there could be other possibilities like 2, 3, 4. Is that okay? Yes, the shorter sides are going to be. What is that also okay? 2 and 3. We have 2 and 3, right? So 2, 3, and then this side could be shorter. Yeah, so 5 may be a little bit too long. Yeah, I said it the wrong way. But 5 is going to be too long. 2, 3 cannot meet the 5 feet piece, right? So in order for them to meet, it has to be straight. But if it's shorter than 5 feet, yes, they can meet. So the 2 sides, if you add the sum of 2 sides must be smaller than their sum. So the 3rd piece must be smaller than the sum of the other 2 sides. Otherwise, if it's bigger, the two sides cannot meet the 3rd side. Like cannot meet the endpoint, the other endpoint of the 3rd side, right? So yes, so you can do that, but you can't do 5 feet with the 2 and 3 feet, 2 and 3 feet, right? So yeah, there we go. This is one combination. There could be other combinations. 3, 4, and 5. Does that work? The shortest pieces, 3 and 4, add up to 7, and 5 is smaller than that. So yes, we have a triangle. 3, 4, and 5. That works too. But 2, 3, and 5 just do not work together. Okay. Yeah, so 2, 3, and 4. 2, 3, and 4, could that be? Yeah, 2, 3, and 4 works. 2, 3, 5 does not work. And then 2, 4, 5. What about 2, 4, 5? So 2 plus 4 is 6, and 5 is smaller than that. So yes, 2 and 4 and 5 works. Yes. And then 3, 4, 5 works too. So the only thing that does not work would be 2, 3, and 5. Yeah. Okay, so they gave us a recommendation. Try all possible combinations of 3 pieces of wood, and we did that. The only combination that does not work would be 2, 3, and 5. Let's look at focus on math practices. Are there any combinations of 3 pieces of wood that will not create a triangle? Yes, we just talked about that. Let's explain. So yes, we cannot use the pieces of wood that are 2 feet, 3 feet, and 5 feet to build a triangle because why? Because the 2 feet long piece and 3 feet long piece. So 2 feet, let's make this simple. 2 feet piece and 3 feet piece lie flat against the 5 feet piece. Okay. So yeah, there is definitely a rule about the size of a triangle, right? So you learn this again in geometry. There's a theorem about this. Let's look at the actual lesson. So the essential question for this lesson is, how can you determine when it is possible to draw a triangle given certain conditions? So we're going to talk about triangles in this lesson. Let's look at example 1. Draw triangles with given side lengths. Students in woodshop class are measuring and cutting out a triangular base for a corner shelf with sides measuring 6 inches, 8 inches, and 10 inches. How can you determine if all the students will cut out the same triangle? So we're going to see if there are any possible ways that they could cut in different ways, right? If we have a combination of 6, 8, and 10. Right? So we could have 6 and 8 have a right angle, make a right angle, and then the third side to be 10 units. And then we could say, using geometry software, try different ways. What if we have 6 and 10 together? 6 and 10 together. But if they're right angle, this side must be longer than 8. So that doesn't really work, right? So the only triangle that works would be where 6 units and 8 units will make a right triangle, and then the third side being 10 units. And if you draw them in different order, you may get different orientation. That means different ways to look at, but they're actually the same triangle. So triangles with the same side lengths are the same shape and size. So no matter how they're positioned, they'll all have the same triangle. Okay, so that's very important to note. Let's look at try it. How many unique triangles can be drawn with given side lengths of 8 inches, 10.3 inches, and 13 inches? We just figured out that any triangle with the same sides are the same shape and size no matter how they're positioned, so they're the same triangle. So if we have all same sides that are exactly 8 and 10.3 and 13 inches, we would probably have one unique triangle. So convince me, when two sides of a triangle are switched, why is it still considered the same triangle? So what if we have this triangle and then that triangle, and then we have these two sides that are switched, right? So here we're switching 8 and 6. 6 and 8 was here, and we're switching this side to be 8 and then this side to be 6. This side is still 10. And if the sides are all together, why are they still the same triangle? Because they're the same shape and size if the sides are all the same, right? So let's write that down. Switching the sides can also be accomplished by flipping the original triangle, turning it, or a combination of both flipping and turning. They're still the same size. Okay, example 2. Determine possible side lengths of triangles. Steve gathers 3 pieces of wood from the scrap pile in woodshop class. Can Steve make a triangle with these 3 wood pieces? 3, 4, and 8. So we just need to check the shorter sides actually. 3 and 4, you add up to 7. So the longest that they could make together would be 7, right? So even if they lie flat, 3, 4, they would have 7 altogether, 7 feet. So there's no way we could have 8 feet with this sum, and it's not going to be a triangle. So you will see like missing pieces over here, right? So what can you conclude about the lengths that can make a triangle possible? So it cannot be exactly equal. The sum of the 2 shorter sides cannot be equal to the longest side. It has to be smaller than, the sum has to be bigger. So the third side has to be smaller than the 2 shorter sides. So this is another rule that we must remember. Let's move on to example 3. Draw a triangle with a combination of given side lengths and angle measures. Can more than one triangle be drawn with the following conditions? Side lengths of 5 inches and 6 inches which make an angle of 45 degrees. So let's try to draw that. 5 inches and 6 inches. We have exact sizes for those sides, and then they need to make 45 degrees. And then you'll have one side that could be exactly that, right? So actually there is no other way to have other triangles because our angle is fixed and then our sides are fixed. And so the endpoints are fixed. So no matter which way you draw, it's still going to be the same triangle. So only one triangle can be drawn with the given measures here. Let's look at part B. A side length of 6 inches with angles that at each end measuring 40 and 60 degrees. So we can use 6 inch and then 40 and 60 here. We can maybe try to flip that. Maybe 60 could be here and 40 could be here, but it's still going to be at meeting at the same point actually. So this is just a reflection of this triangle, but they're actually the same shape, the same size. So only one triangle. So if you have a fixed angle with 2 fixed sides, so side, angle, side. This is actually a theorem in geometry. Okay, SAS. There's only one way to draw a triangle like that. And also angle, side, angle. So if you have a fixed side and fixed angles for 2 fixed angles for that one side, then there's only one way to draw the triangle too. Okay, so this is the side postulate theorem, and then SAS theorem and ASA theorem in order to remember them correctly. But if you have 2 sides and then a random angle like over here or over here, there are many other ways to draw that triangle. This angle must be in between these 2 sides. Okay, so this one, pay a close attention to that angle right there. Angle must be in between those sides. Yeah, let's look at try it A and B. Write 3 side lengths that will form a triangle. Write 3 side lengths that will not form a triangle. So give an example for each. And then part B, can a triangle be drawn with a side length of 3 inches and angles at each end measuring 90 degrees and 89 degrees? Explain. So pause the video, think about this, and try to answer it yourself. Come back when you're ready for answers. Okay, let's look at part A. So give an example. Yeah. I wonder what your examples are. Yeah, if you could share that in class or write it in your notes, or if you're looking at this from another country, maybe write it down in the comments. I'd be interested to hear your thoughts. But 3 side lengths that will form a triangle could be any combination where the 2 shorter sides are bigger than the 3rd side. Okay, so you know, 4, if you've picked 4, maybe 4 centimeter, 5 centimeter, the sum of that would be 9. So it cannot be exactly 9 or bigger than 9. The 3rd side must be smaller than 9. So 7 or 8, right? So combination of that is a triangle. And then combination, let's do the same thing, 4 centimeter, 5 centimeter, and then it fits exactly 9 or bigger than that. It will not form a triangle. Okay, part B, can a triangle be drawn with a side length of 3 inches? And angles at each end measuring 90, okay, and 89. Ooh, so this is like almost 90 degrees, but it's like not. So then it's like gonna be super long. And so the triangle is gonna be really, really long. But can it be possible? Yeah, as long as these 2 lines meet at some point, which they will because this one's 90 degrees, and they're not parallel because this one's not 90 degrees. It's like 1 degree. Like it's not 90 degrees, right? So then it's going to meet that side, the other side. So yes, the end of the triangle would probably just be 1 degrees because the sum of triangle would be 180 degrees for the angles, right? So the sum of the interior, like inside, interior angles of a triangle is 180 degrees. And so the 3rd side, the 3rd angle will be 1 degree. Okay, let's look at example 4. Draw a triangle with 2 given side lengths and a non-included angle measure. Can more than one triangle be drawn using 2 side lengths of 6 units and 9 units and 40 degrees angle that is not formed by their intersection? So draw a triangle ABC with side lengths 6 units, 9 units, and a non-included angle of 40 degrees. So yeah, so included angle is this one, included angle. Okay, non-included angle is 40 here or 40 here. Okay, we just chose this one. You can, yeah, so this angle could be any angle, that angle could be any angle. They just need to be 9 units and 6 units. The sides must be exactly 9 units and 6 units. So yeah, your triangle could look like this. Your triangle could look like that because the other 2 angles don't really matter. So more than one triangle can be made with these given measures, which I shortly mentioned. So this is why SAS is important. This only works when you have an angle in between the sides. So there's only one triangle. But then if you have just angle in other, not included, so side, and then you have an angle somewhere else, there could be 2 triangles. So more than one. So this one doesn't really work for one triangle. Let's look at example 5. Draw a triangle with 3 given angle measures. Is there a unique triangle with angle measures of 30, 60, and 90 degrees? So if you have all same angles, right? What if, because we have if we have fixed side measures, then it's going to be one triangle, right? What about 3 same fixed angle measures? As you can see here, the angles can be the same, but then the side lengths don't have to be a fixed length. So then the sizes are going to be different. Then they're going to be the same shape, but they're not going to be the same size. So then you can't say they're the same triangle. So when we say there's a unique triangle, is it going to be same shape and same size? So for this one, for the same angle, yes, they will have the same shape, but they will not have the same size. So there is no unique triangle. Yeah. So many different triangles. So the only way you will have one unique triangle is the side, 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 and then side, angle, side, where angle is included angle. And then you have, what else did we look at? Side, angle, side. Yeah, SSS, SAS. Is that the only thing we looked at? Okay, sure. So yeah, just SSS and side, angle, side. Let's look at try it. Can more than one triangle be drawn with 2 side lengths of 6 inches and a non-included angle of 60 degrees? We already know that. 2 side lengths of 6 inches and non-included angle of 60. So this needs to be 60 or that needs to be 60. But then you have 2 of the same sides. So pause the video, think about this, and come back when you are ready for answers. Okay, are we ready? So this is a special case. When we have 2 equal sides, even though this is not an included angle, what do we know? Because this is 6 and 6, and that's 60 degree, the other two, this one is an isosceles triangle. Even if we have this way, the angle must be the same. So there's only one way to draw this, because that must be 60, because these two sides are equal. So then if this angle is 60 and that angle is 60, the included angle must also be 60, because the total sum of the interior angles must be 180. Does that make sense? So then this is an equilateral triangle. So if we have 2 of the same sides that are exactly the same, side and then same side, and the angle must be 60 degrees, then there's only one way, right? Yeah. So in this case, there cannot be more than one triangle. So no. If 2 sides have the same, so let's explain that in words. If 2 sides have the same length, then the triangle is isosceles. That means you have 2 same length and has 2 equal base angles. Base angles just means these 2 angles on the bottom of 60 degrees. 60 degrees. This means only one equilateral triangle with side lengths of 6 inches can be drawn. Okay, there. So that is all about triangles. Let's look at key concepts to summarize our lesson. You can analyze given conditions of side lengths and angle measures to determine whether one unique triangle, more than one unique triangle, or no triangle can be drawn. So you can have only one possible triangle given that all three angles or two sides and a non-included angle. Wait, this is more than one possible triangle. So this is not unique. If the angles are fixed and then side A, like there's an angle that is not included, then more than one unique, not unique, okay? And then if there are sides that are fixed, all same three sides that are fixed, and then side and then angle side, then you have angle side angle. Oh yeah, we talked about angle side angle. Then this is unique triangle. Okay, I hope that was very clear to you. This was lesson 10-3, draw triangles with given conditions. We'll continue with the next lesson in the next video. Bye!